Welcome to our introduction to Docker. In this lesson, we'll explore the basics of Docker and how it can help you deploy applications efficiently. Docker is a leading containerization platform that enables you to package your application and its dependencies into a single container. This container can then be deployed on any system that supports Docker, without worrying about compatibility issues. Let's dive into the world of Docker and discover its power. By the end of this lesson, you'll have a solid understanding of Docker and its capabilities. You'll learn how to install Docker, run your first container, and understand the key concepts of Docker. We'll also cover the basics of Docker CLI commands so you can start managing containers like a pro. Let's get started and achieve these learning objectives. So, why does Docker matter? Well, it solves a major problem that developers face: inconsistent environments and dependencies. With Docker, you can package your application and its dependencies into a single container, ensuring that it runs consistently across different environments. This saves time and effort and enables efficient deployment of applications. Let's explore more about Docker and its benefits. Docker is not just a theoretical concept. It's widely used in the real world. Many companies, including Google, Microsoft, and Amazon, use Docker to deploy their applications. It's used in a variety of industries, including web development, DevOps, and data science. Docker enables efficient deployment of microservices and cloud-native applications and provides a secure and reliable way to deploy applications. Let's see how Docker is used in the real world. Now, let's dive into the Docker architecture. Docker uses a client-server architecture with a daemon and a client. The daemon runs on the host system, managing containers and images. The client is used to interact with the daemon, sending commands and receiving output. Docker uses a registry to store and manage images, including Docker hub.di. Let's explore more about the Docker architecture and its components. Now, let's explore the Docker components. Docker images are the building blocks of containers, containing the application and its dependencies. Docker containers are isolated from each other and the host system, ensuring security and reliability. Docker volumes provide persistent storage for containers, enabling data to be shared between containers. Let's see how these components work together to enable efficient deployment of applications. Now let's run a Docker container. We'll use the Docker CLI command to run a container from the Ubuntu image. We'll specify the IT option to run the container in interactive mode, and the name option to specify a name for the container. Let's see how this works. Now, let's explore some Docker CLI commands. We'll use the Docker PS command to list running containers, the Docker stop command to stop a running container, and the Docker arm command to remove a stopped container. Let's see how these commands work. Now, let's create a Docker file. A Docker file is a text file that contains instructions for building an image. It specifies the base image, copies files, and sets environment variables. Let's see how this works. Now, let's explore Docker Compose. Docker Compose is a tool for defining and running multi-container Docker applications. It allows you to define services, networks, and volumes in a single file. Let's see how this works. Now, let's talk about Docker volumes. Docker volumes provide persistent storage for containers, allowing data to be shared between containers and persisted even after a container is removed. Let's see how this works. Now let's talk about Docker networking. Docker networking allows containers to communicate with each other and provides a way to configure networking options. Let's see how this works. Now let's talk about Docker Swarm. Docker Swarm is a tool for managing and orchestrating containers. It provides a way to manage multiple containers and to scale applications. Let's see how this works. Now let's talk about common mistakes. There are several common mistakes that people make when using Docker. Let's see how to avoid these mistakes and use Docker effectively. Now, let's talk about best practices. There are several best practices that you can follow to use Docker effectively. Let's see how to use these best practices to deploy applications with Docker. Now, let's talk about optimization. There are several ways to optimize Docker containers and images. Let's see how to use these optimization techniques to improve the performance of your Docker containers. Now, let's look at some real-world examples of Docker in action. Docker is used by many companies and in a variety of industries. Let's see how Docker is used in the real world to deploy applications and provide a secure and reliable way to deploy applications. In conclusion, Docker is a powerful tool for deploying applications. It provides a secure and reliable way to deploy applications and is used in a variety of industries. Let's summarize the key points of this lesson and see how to apply them in real-world scenarios.